So I know what you mean about like things bisecting, but what do you mean about a trisection? You just mean like 3 lines coming together?
Okay. Like a line and then just like split into 3 parts, and all 3 of those parts are congruent to each other.
Yeah.
Like.
So it's like subdividing, right?
Okay.
So anytime we're dividing things out into equal segments, you can do that with any amount. You could make it infinitely small if you want. So we got to talk about when do we want to take your Chapter 2 Mastery? I don't care, as always. And because Chapter 1 Mastery was group and we all did perfectly fine on it, I don't even know if we're ever going to be like, you guys all mastered it, it's fine. I don't think I'm going to put it in math. It was a lot of review, right? Chapter 1 was a lot of like, let's just get that going again. So, for Chapter 2, it will be an individual mastery, right? Regular test setup. When would you like to take that? Friday? I know we have a cookout, so that's going to impact the schedule a little bit. So I would, it's during school. Cookout.
Is it the Outsiders Day?
Yeah, but I don't know if they'll be done. They just started the Outsiders. I think the cookouts earlier this year. Yeah, HSM2 do things up. So,
I'm fine with doing it tomorrow.
that or we could do like Thursday into Friday if necessary.
I feel like tomorrow would be good because we just finished Chapter 2. We wouldn't be learning different things.
Yeah, it all builds. I mean, you're learning continuation. All right, so votes for like ASAP, like tomorrow. Who's voting for like just let's get it on with it? Votes for Wednesday. Votes for Thursday.
So it's all pretty soon though.
Okay, so yeah, I'm still tweaking your test because like every year I'm remaking things. So assuming I get that done tonight, which I guess I will. You might want to before I move on and change the slides because then we're moving quick and we're gonna.
I have so many questions. If I can find, turns out that.
Same as last time.
Yeah, I went to a different geometry math class and they taught something completely different.
Where? When? In your dream, or what are you talking about?
They weren't teaching similarity; they were teaching another part of geometry.
Where? Like, what are you talking about?
You just like said I went to another class.
But you didn't actually?
No, I did.
Where?
At Thomas.
Oh, okay. And?
They taught me something else. It was like about.
Was it a Math 2 class?
Yeah, it was geometry. Well, they call it geometry.
But no. If it was Worthington, they shouldn't. We took the integrated pathway as a district. So it might have been an elective class all about geometry, but if it was the same class as us, it should be called Math 2. Okay. All right. So what we're going to talk about today is some genetics. So when we talk about using the area model, we can use it for binomial applications. We are actually going to use it to factor our quadratics later in the year. We use the area model for a lot of things. But today we're going to use it to analyze probability of certain gene characteristics, right? So certain traits. So if you have what's called a hitchhiker's thumb, your thumb can bend backwards. I have a very dramatic hitchhiker's thumb. If your thumb only gets to straight and that's it, you don't, right? So hitchhiker's thumb, not. Real life, right? It is super bendy. Very, very hitchhiker's thumb. So we're talking about the knuckle of your finger, not down here where it connects to your hand, but does that knuckle bend backwards? So the probability. Now this is really interesting. We actually do ask these questions, and I have a survey at home that I need to fill out. That is the 2020 presidential survey, but it is the 23rd all day long. According to this table, half of people said yes, they can bend their thumb backwards, and half of people said no. According to this table, also with whether you can roll your tongue, like actually like make it like a W. Can anyone in here do it? Like you can like bend your tongue like a W? Like, well, so I forget. Maybe it's not talking about. I think it might just be talking about like roll it like into a straw. No? Yeah. Yeah. Some people can, some people can't. Like, it's just our genetics. It's how our tongues work. So, that's not true, though. That's not true, though. The real math that we're going to draw, hopefully you did not draw your area model yet, and as we draw area models, we want to try to size them appropriately. So if we have a 1/4 compared to 3/4, we want the 3/4 space to be bigger. If we have a half and a half, we want them to be relatively equal to each other. So let's create an area model table that is accurate, right? 1/4 of the U.S. population can bend their thumb backwards. So I'm in the minority, right? But I have the awkward ability to bend my thumb backwards like this. However, 7/10 can roll their tongue apparently. So that is a much easier thing to do than bending your thumb backwards. So like they had with that area model, except fix it to be accurate, go ahead and draw that on your paper and fill in the insides of it. Fill in the insides of it.
I'm really hungry.
I'm sorry.
He's eating this. I really want it. I want to, but I don't have time.
Did you say it's called go to a pastry shop? Or you could make pastries?
I don't know. These are homemade. I think I have more time to work. Not your homemade. No, my homemade is like they make, not in our home, but they make it. Like, oh.
They're made from somebody's home?
Well, yeah. They're not all like my dad is friends with the owner, and he sends us these for free.
Now, in reality, it would be better if you start to make these as squares, right? Like the region as a whole. Because when we're talking probability and percent breakdown, it makes sense that 100% going one direction and 100% going the other direction would be like the same size, but because my screen is a rectangle, I naturally just kind of draw a rectangle. So if I try to fix that and make it more like into a square,
I don't know if mine's a square.
yeah, just try to make it close.
I could count and figure it out.
Ooh, you could because you're on graph paper.
Yeah,
How fancy.
Why would I do that?
So for our thumb, 1/4 of people can. Yes, so that's a 1/4 can. Make that smaller than my region that is no, which is 3/4. For my tongue rolling ability though, how many can? 7/10. So then the no would be 3/10, right? So what is the probability that you can't do either? Or what is the probability that we can do both? Like, how do we figure these things out? I mean, another way I guess we could write these things is in decimals. What do you mean?
So we're trying to find the yeses. We multiply the two numbers together.
So you say do 1/4 times 7/10.
Yeah.
So numerator, numerator, denominator, denominator. 7/40. What would go here then for the no and yes? 21/40.
And then 3/40.
And then, how do we check if we did this right? Yep. Our area model table, one of the reasons why we use this is we know one reason for probability that the whole thing has to equal 1. So whether I look straight across my tongue and I do like 1/4, 3/4, or straight across for thumb or straight down for tongue, we get 1. Whether we go across there, add up the whole thing. So we can use this to find unknown probabilities, right? If we have a probability of one trait and then we also have one other piece of data, like any of the pieces that can fill in here, we can actually use this to work backwards in a way and figure out these probabilities that would go on the outside. So we did that. So let's talk about blood types. Was it this class that we were getting into, like blood types being compatible and not? And
I don't think
But I know about that.
I know.
what do you know about that?
I know that like if like you need blood, like your donor has to be like the same blood type
potentially.
So that it doesn't. Will the chances of like your body might not recognize that blood and treat it as like
And reject it.
But then like
Unless
negative
it's what's
Wow.
isn't it O negative that
I know that like if two parents.
Hey people, while I love our casualness, 4 people talking at once doesn't work. So Sammy had her hand up while David was talking. Sammy.
But isn't it O negative that would work like
Certain ones are universal donors. Sammy's thinking about.
So the way it works is it's like which type you have like represents like how many of the certain thing you have in your blood. I can't remember what it is.
It has something to do with like hemoglobins or
Yeah.
hematokins.
So that's like by some work is because like if you have too many, I think it'll like reject them. But if there's like fewer than you have, then it'll still work.
And I don't know all the deep nitty-gritty science here, but what I do know is some of the math behind it. So absolutely, blood type determines who you can donate to or who you can receive a donation from. If you're curious about digging into the, what's that called?
A and B are
Hema means blood. I just forget what the science of it is. But yeah, dig into it. It's really interesting. So one really interesting trait about the Navajo population, or like Navajo Indians, and we can read here, but like members of the American Navajo population can be classified into 2 groups. 73% have O blood, and 27% have A blood. There's no B blood present in the Navajo population. Because if we think about where your blood type comes from, it is traced back to wherever you came from, right? And if all Navajo people are related to each other and they all go back to the same like hereditary line, there was just no B blood type there, and B blood type can't just happen, right? Like your blood type comes from your parents. So here's our table with this. So do a quick little sketch. Now this is analyzing the same stats 2 different ways, and I disagree with how their table's drawn because they split it evenly. And I don't like when things don't look like they should. Oh, here it is. Antigens. That's where your blood.
Oh, it literally says it there.
This is why I like CPM too. They explain things beyond just the math. Sometimes it's way easier to use a calculator and use decimals. So we use 0.73 times 0.73. What goes here? I think it's close to half.
Yeah, it's 0.53.
53-ish. Well, that's a squiggly. You didn't squiggle very much. What about 0.27 times itself, like 0.27 squared?
0.0729.
What do we know about the other 2 boxes? They're equal, because we're only comparing 2 traits. And we have like a yes and a no and a yes and a no, which here is like O versus A. But really, we're just saying like it either is on or off. Right, so, sorry, that's not a negative. I want to be really clear with that. That's a squiggly. Yes, that is a squiggly. So, 0.27 times 0.73.
0.1971.
So when we analyze this table, these actually go together. Right, because this is, if we talk about like where your blood type comes from being where you came from, right, the 2 people that got together to make you, if you are a Navajo person, are either blood type O or A. So the chances of you ending up, I mean, if you have A blood and A blood, you're going to end up with A blood, right? If you have A blood and O blood, that's where it comes into like, you're not quite sure. It depends on what depends then. It might be dominant. You're probably right, but our bodies are very complex. It's just like that's not a sure thing.
It may be likely, but not sure.
Because then there would have to be only O's.
Yeah, so the highest chance here is a Navajo person's most likely going to have O blood, right? Because that's a 53% chance that they have O and O. That doesn't mean for sure, right? That's only just over half. But that's the chances that we can just say, all right, you got O blood. And O blood is, depending on if it's the positive or negative, it is universal donor / receiver.
And you could go back to like generations and say both of them were O, but like their parents like A and O.
What's recessive hiding in there? Yep. What is hiding in there that you don't know about?
Because the parents could both be the same, but then you're different because of it.
Right. All right, well, let's take this a little bit further. So, we decided to go on an expedition for Discovery Day, and unfortunately, we crashed. So, unlike the Navajo people that are all related closely back to, one genealogical line, we know that normal American populations have 4 blood types, right? A, B, O, and AB. AB is its own blood type, even though it uses the letters from the other one. So, this starts to go into who can donate to who, right? So you've got your data up there, like 40% A, 45% O, all that. But, so here's our table, right? We're not quite sure what Nick is, but we know the demographic population data. And we're not quite sure what Zach is, but we know the data and we can set this up. When they ask what's the probability they have matching blood types, I want you to work with your partner to try to figure out how do I answer, because it's not just looking at a box on the table. Right? It's not just looking at a box on the table. How do we answer what's the probability of matching blood type? I bet you can do this in under 5 minutes. I bet we can have this done before the big hand hits the 12. What are you confused about? We are essentially trying to fill in this table, and then we'll be able to answer our questions.
Hey, Leanne, you want to join us so we can just use your calculator? Yeah, I got my phone.
Grab it.
So this gravity because Liang.
Yeah, gravity because Liang. Wait, do we have to make the boxes not?
No, you can just make these the same, relatively the same size. Do we have to fill in the whole thing?
No, because it's just to see what the probability is that they're the same.
Yeah, so if we're just trying to answer the question they asked us, we don't need the whole thing. So here,
Wait, percentages or decimals?
either. Percent's probably easier because you don't have so many 0 point. Here is the map of donors receivers. Right up there off to the right. O can give to anybody. A can get from A or O Any blood can obviously get its own type back. B can get from O or B, and AB can accept O or A or B.
Wow.
So AB is like a really good blood to have because it can accept all of the blood.
Universal receiver. Yeah. It's like I'm the universal donor because I'm O type, but I'm not a universal receiver.
I'm the universal useless because I'm the.
Wait, so A is a universal what?
Because you're what?
A can receive, any blood can receive its own type, right? So A can receive from A or O. B can, same story, B can receive from O or
I
B.
don't know what an AB.
AB can receive from anybody.
Oh, should I know
So
what
A-
type I am?
Nah, your parents probably do. If you
Well, if you know your parents, then you're probably old.
I don't know what
once you're old enough to donate blood with the Red Cross too, they will like give you all that information. I
So they
just
know what it is, but I
just
don't know
got in
what
the
it is.
mail. No, this might gross you out, so sorry if it does, but I just got in the mail my pin for donating, but like pin that you wear, for having donated 7 gallons of blood in my life.
Whoa. Well, it's because you're an O. So.
Yeah, because they hound me every time I'm able to donate. They're calling me, they're emailing me. They're, hey, you want a free Cedar Point ticket? You want a free T-shirt? You want to come give us your blood?
And you got all of that?
Yeah, normally I don't take it. Sometimes if it's like a free, well, what if it's like a buy one get one ticket? I might take that. But like T-shirts, I don't need more T-shirts.
Do they like do the
Like, hey, you want this free stuff so we can take
Do
it?
you really want to know? Like I will tell you.
I have the math answer.
Nice. Hold on. Before we get back to the math answer, so 2 answers to your question, David. Normal blood donation, they just stick a needle in your arm, and they have a cuff, like a blood pressure cuff, and they can like tighten that if they want to slow your blood flow down, or loosen it. And as soon as you're done, if you just put your arm up, the blood doesn't like it flows down to your body, right? So it's not still coming out. So then they just put a bandage on it, and you're just done. Like they just
So
take
your
your
arm
blood.
isn't
They took my blood
Might be a
once.
little bit sore, but so
Blood before, and I'm like, I don't like it. It's just, I don't like it.
for O donors, this is where the science gets super cool. Because we're a universal donor, they can do this process with your blood that they call power red, and they used to call it double red. And what they do is when I go to donate, they actually hook me to a little machine, and when the needle goes in my arm, there's actually 2 tubes on it.
What?
One
They take
is
even more blood?
no, one is taking the blood out. The other is giving you back everything that they can make in a lab. So in a lab, they can make platelets, they can make plasma, they can make every part of your blood except for the actual blood cells.
Ah.
A body has to make those. So no, they give me mine. So here's how this works. They pull just listen. They pull the blood out, right? It goes into a machine and they spin it really fast in a centrifuge, right?
Yeah.
From there, the blood separates. Red blood cells and platelets. So part of that machine, as soon as it separates, is it pulls out the red blood cells and it puts them into a bag, like literally the bag on the side of the machine, and it pulls out the platelets and plasma. And when it has enough, this little thing goes up and it's like, and it sounds like I've like leveled up. And they're like, I'm not joking, I'm telling you like for real. And so I have like a stress ball, right? And you're squeezing it to make the blood flow happen. And they're like, hey, stop squeezing. And it will give you your platelets and your plasma back.
But not
And
your
you do
blood.
this twice.
So
Wait,
they
why do
keep
they
the
do
red
that?
blood
Your
cells.
platelets and plasma?
Because they don't need them. And then I feel normal. When I leave, I don't feel like anything has happened because all they took from me is red blood
So
cells.
what would happen if they took away your platelets and plasma?
You just feel a little like tired and a little sluggish.
Is the water in the red blood cells? So what is the red blood cells by itself look like? Is it
Just
like
really dark, like
Blood.
pretty
How,
much it.
wait, I don't get it. By spinning blood really fast, you can separate it from platelets and what do the
They have
platelets
different
and
viscosities.
plasma look like?
Kind of clearish. They put an anticoagulant in it. This is where it gets really interesting.
Oh, so it doesn't.
So it doesn't clot as it's going back into, but because that anticoagulant is now in what's going through your body, you end up smelling it. Although you're not smelling anything. It's in your veins.
What?
So the thing that they put in it to make it not clot has like a metallic-y kind of like property to it.
What the heck?
So have you ever smelled iron? You know what I'm talking about? Like,
Actual heck.
it seems like you're smelling that. So I ask questions all the time. So the first time I was there, I was like, am I smelling like metal? And he's like, oh, you're smelling your stuff we just put back in you. Isn't that so cool? Because the science behind this. Like, this is all new. This didn't exist when I was your age. The ability to do this. Like, this is why I'll go into these things. You can donate blood once you're 16 now. I think if you're big enough. All right, here's what your table should look like. All we really need is that box, that box, that box, and that box. I mean, we normally go to 2 decimal places if we're able to. So approximately 38%. Right? There's an approximate, just random, if we don't know anything, there's a 38% chance the blood types match.
That's not very good.
Well, honestly, for being random, it's not that bad.
Yeah.
I mean, 40% just for a random, like, on a hope and a prayer. Now, then, though, we start being asked, well, what about if they don't have to match?
They just have
What?
to be able to.
Ooh.
Oh.
What's the probability that he can receive? So,
He's AB, then I'm scared.
Who needs to receive it?
Wait, so they crashed on an island.
So wait, okay, so
What
he's
happened?
AB. Then he's like, yeah, he's safe. He's good. But he's an O or like an A or B, then it depends. Okay, there's 2 things. So if the receiver is AB, then it's 100% chance, and if the donor is O, then it's 100% chance. So it's 50% chance already.
If the
When did this
receiver
get
is
into
AB,
science
then
and
it doesn't matter what the donor is.
Yeah. Well, that's a.
you are correct, yeah. If the receiver is AB, so, hold up, exactly what you're saying. If the receiver, who's getting blood, Zach, I think? Yeah. If the receiver, Zach, is AB, any of these work, right? Any of the donors.
So his highest chance is.
If, hold up, let's go one piece at a time. If he's O, what does he need?
He needs
O, right? O can only get from O. So this is the only part of O that we can use. If he's A, what can he receive?
O and A.
O or A, so both of these.
So it's a higher and higher chance.
B, what could he receive?
the 3
O.
from O A. I mean
No,
O or B, right? O or B. And then if they're AB, we say we can use all of these.
So,
If we
so
add
if
all of
he's
those
AB,
up,
then he's fine. If he's O, he might be doomed.
Yeah. if you're the O blood type, you are the one giving everybody else your blood. Like, I guess I'll save you.
I guess I'll say.
Yes.
I want
All right.
to be AB. I'll just suck up everyone's blood.
Vampire?
The last thing for us to talk about, and I knew that this lesson was kind of quicker, that's why I let us go off on the tangent about blood and everything else. Is there, and this might be beyond what we know, because I don't know very much about this, but this says blood types affected by genetic inheritance. So, what if Zach and Nick were related to each other?
Oh, and then their blood type should be the most likely.
If they're related to each other, then it should have a higher probability that one of them will survive.
So, if they were brothers with each other,
They would probably
Have a
have
better
the
chance.
same. Most likely they'd have the same, but
Now
there's always
this
a
will never
chance.
happen.
I don't have the same blood type as my siblings.
I said there's a-
It's
most likely, but not.
So, this gets into the dominant and recessive and that whole sort of thing.
Oh,
But does the application of our area model to solve probability questions, does that make sense?
yes.
Sweet. So then we can use the last 10 minutes to work on homework.
Nice fun.